Hi, in this video of import, we'll study the matrix representation of a linear transformation. The approach of studying linear transformations via matrices makes it easier to study the linear transformations as we can utilize many properties of matrices. So let's start with some definitions. We already know that a basis for a vector space is a subset of the vector space which is linearly independent and it spans the vector space. Now comes an ordered basis. So if V is a finite dimensional vector space, then an ordered basis is a basis for V endowed with a specific order. So ordering means that you know which element is the first element, which is the second element, and so on. So basically the ordered basis is a finite sequence of linearly independent vectors which generate the vector space. Okay, so what is sequence? Sequence is nothing but a function from the natural numbers to the space in which you are considering the elements, right? अगर xn एक सीक्वेंस है किसी वेक्टर स्पेस x में, तो xn क्या है? एक फंक्शन ही है नेचुरल नंबर से, तो 1 इज करस्पॉन्डिंग टू x1, 2 इज करस्पॉन्डिंग टू x2 एंड सो ऑन. तो जब कोई भी अगर हमारे पास वेक्टर स्पेस है उसके हम बेसिस को ऐसा एक करस्पॉन्डेंस दे देते हैं, राइट? तो मतलब उसके एक बेसिस को हम एज अ फाइनाइट सीक्वेंस लिख रहे हैं, तो उसको हम ऑर्डर्ड बेसिस बोलते हैं. नाउ एन ऑर्डर्ड बेसिस फॉर अ फाइनाइट डिमेंशनल वेक्टर स्पेस, let's say it is beta, so the vector space is V and beta consisting of u1, u2 and un is an ordered basis. So now because beta is a basis, so you can represent any element in V as a linear combination of elements of beta, right? So for x and V there exist finite elements or scalars in the field, and these are unique because it is a basis, so the representation is unique such that x is equal to summation ai ui. Then we define the coordinate vector of x relative to beta, which we denote as this vector, this element x beta. This is defined as the matrix a1, a2, this column matrix consisting of the scalars a1, a2, an. So this is x beta. So now also since we know that Fn is a vector space, right? So this consists of all the elements of the type n tuples a1, a2 and so on an, such that ai belong to F, right? And also basis for Fn consists of the elements ei, where ei is nothing but 0, 0, 1, 0 and 0. Here 1 is at the ith place. Okay, so this is such a set that is for F2, let's say the set becomes 1, 0 and 0, 1. For F3 it becomes 1, 0, 0, 0, 1, 0 and 0, 0, 1. So such a set is a basis, and this basis is said to be a standard ordered basis for Fn. Okay, so remember this is the standard ordered basis for Fn. Okay, let's consider an example. So we start with the vector space V is equal to P2R, consisting of all polynomials with degree less than or equal to 2 with real coefficients, and an ordered basis for P2R is given by beta is equal to 1, x and x squared. So if we consider the polynomial fx is equal to 4 plus 6x minus 7x squared, then the coordinate vector of f relative to the basis beta is given by f beta. This is given by 4, 6 and minus 7. Similarly, if we consider the polynomial gx as 2 plus 3x plus 5x squared, then the coordinate vector of g with respect to beta is given by 2, 3 and 5. And for hx is equal to 2x, let's say the coordinate vector of H with respect to beta is 0, 2, 0. Now we come to the main thing, that is the matrix representation of a linear transformation. So we start with two vector spaces V and W, which are finite dimensional, and V has an ordered basis beta consisting of V1, V2 till Vn, and W has an ordered basis gamma consisting of W1, W2, Wn. And T is a linear transformation from V to W. अब क्योंकि हर Vj के लिए, where j lies between 1 and n, T Vj, where does it belong? It belongs to W, right? And W has the basis W1, W2, Wn. So we have done a theorem which says that every vector in the vector space can be uniquely expressed as a linear combination of the basis elements. So because T Vj belongs to W, so there exist unique scalars Aij in F such that every T Vj can be expressed as summation I varying from 1 to m Aij Wi, right? Why have we taken Aij? Because we want to associate these scalars to every vector Vj. Okay, so these are unique scalars, and now we define the matrix A as the entry of ijth entry of A is given by Aij. Then this matrix is said to be the matrix representation of T in the ordered basis beta and gamma. And this is the notation for this matrix representation. And if V is equal to W, that is T the linear transformation from V to itself, V to V, and beta is same as gamma, the basis is also same, then we write simply A is equal to T beta. So we shall understand it with examples and it will be more clear. So we start with a very basic example. We consider a linear transformation from R2 to R3. So remember, when F was a field, Fn was a vector space, and we just now mentioned it had a standard ordered basis given by Ei, where Ei is 0, 0, 1, 0, 0. The 1 is at ith place. Okay, so this is a basis for Fn. And here I varies from 1 to m. Okay, so T is from R2 to R3. T is given by T A1 A2 is equal to A1 plus 3A2 0 and 2A1 minus 4A2. So this clearly belongs to R3, right? So now beta is the ordered basis for R2 given by 1 0, 0 1. Let's call these vectors as, this is E1 and this is E2. And gamma is the standard ordered basis for R3. Let's call this as E1 prime, this as E2 prime, and this as E3 prime. Now to find T of beta gamma, we have to express Te1 and Te2 as a linear combination of E1 prime, E2 prime and E3 prime. So what I am saying is, let's first of all find T of E1, which is equal to T of 1 0, and T of 1 0 is 1, 0, 2. So you can write this 1, 0, 2 as 1 into E1 prime plus 0 into E2 prime plus 2 into E3 prime, right? And now let's find T of E2. T of E2 is what? T of 0, 1, and T of 0, 1 is 3, 0, minus 4. So this can be written as 3 into E1 prime plus 0 into E2 prime minus 4 into E3 prime. So we have got these unique scalars, right? And we have expressed Tei for I is equal to 1 and 2. So the matrix T of beta gamma is given by 1 0 2. First of all, we write the scalars corresponding to Te1 as a column, and then the scalars corresponding to Te2 as the second column. So 3 0 minus 4. So this is T beta gamma. Such questions are asked in exam, so it is better to practice such type of questions. Let's consider another example. So now we consider linear transformation from P3R to P2R. Note that for P and R, a standard ordered basis is given by 1x, x squared, and so on, xn. So we consider the mapping T as T of fx goes to f dash x. That is the derivative of the polynomial fx. So now let's consider the basis. So beta is the basis for P3R, which is the standard ordered basis, that is 1x, x squared, and x cubed. And let's consider gamma. So this is the basis for P3R, and gamma is equal to x1 and x squared. This is the basis for P2R. Now note that this gamma is not the standard basis for P2R, right? Because the ordering is different. In this basis, standard basis for P2R, we consider 1x x squared, but in gamma we have x1 x squared. Now let's calculate T of 1. So T of 1 is f dash of 1, which is 0. So this is equal to 0 into x plus 0 into 1 plus 0 into x squared. Now T of x. So T of x is 1, which is 0 into x plus 1 into 1 plus 0 into x squared. T of x squared is equal to 2x, which is equal to 2 into x plus 0 into 1 plus 0 into x squared. And last, T of x cube is equal to 3x squared, which is equal to 0 into x plus 0 into 1 plus 3 into x squared. Now the matrix T of beta gamma, how do we write it? The first column will be the coordinates corresponding to T1. Okay, so the coefficients corresponding to T1. So it will be 0, 0, 0. The second column would be the coefficients corresponding to Tx. So it will be 0, 1, 0. Third column would be the coefficients corresponding to T of x squared. So it would be 2, 0, 0. And the fourth column corresponding to Tx cubed, it would be 0, 0, 3. So this is T of beta gamma. You can practice with the same linear transformation by taking different bases. Okay, so you can consider then another basis beta dash to be equal to say x, x squared, 1 and x cubed, and take gamma to be the standard basis, that is 1x, x squared, and then find T of beta gamma, gamma dash, let's say. So you can find T of beta dash, gamma dash, and you can practice such questions.